Welcome to today's lecture on soil productivity in land evaluation. Um I thought I'll get time so that maybe I can try to find one example, then we can solve together. But then today I have no enough time, so I'll just try to explain and perhaps also use the example that is in your lecture notes to explain it further, and then give a hint on how you can solve the exercise that you're given or the assignment that you're given. I guess that way it also help. I thought of maybe we can explain and then you can get something from there that you can have a starting point. Now, just a quick introduction, quick and simple introduction. So, productivity basically is just how you are just looking at how suitable the soil is, and to provide the needed nutrients for a crop to grow. And then it gives you, you are trying more like to quantify the suitability of that soil in terms of percentages, and then that percentage then tells you the percentage of yield that you can expect from the maximum yield that you can ever get, say in 1 hectare of land. So to find the productivity of a soil, you use a productivity index, which simply where you are indexing, okay, you are compounding, so to say, where you are compounding the sufficient levels of different parameters that you would have defined in depending on the soil type or the situation of the soil at that particular moment. Now, productivity index is simply then found by compounding, and when compounding, normally multiplication sign is used. Why? It's because then it takes the more like the concept of minimum, okay, or in other words the concept of limiting factors. So you realize that if you have, let's say, 5 elements or 5 components that you're considering, say pH, is it bulk density, and all these other components that are necessary for the plant, then if there is any among those that is the least, then when compounding or when multiplying, you realize that that factor is taken into consideration. So that means that will be a limiting factor for you not to reach 100. Okay, so that is why multiplication is used. Now, when multiplying, we also take into consideration the WFI, which is simply root weighting factor. This one is based on the depth of the root zone, okay, the depth where the roots are from the surface. Okay, now then this one is simply found by this one is simply found by this one is simply found by subtracting the maximum depth. So this is the formula here. So the maximum depth minus the minimum depth, or the upper boundary, the smallest, because you are given it in ranges. So given that range, then the lower boundary, you subtract it from the maximum, you square that answer, and then minus the maximum again, you subtract the lower boundary. Now, okay, you understand maybe as we go down. Okay, so now, okay, here it is. So like in this case, this is for this particular zone here, this is our lower and upper. Okay, so the maximum is 100, so you just say 100 minus 0, you square this one, minus 100 minus 20, then you square your answer, then over the maximum, which is 100 squared. So you get your answer at this particular area, zone. Also, when you come to zone 2 here, when you come to zone 2, the same, only that now this one will become your your upper and lower. So you say 100 minus 20, then 100 minus 50 over 100. Again here on 3 you have the same. You have 100 minus 50, which is the lower, then minus, or the upper, minus 100 minus 100, which is 0. Okay, then over 100 squared. Okay, now in this this is I think this should be an example or something. Here you need another table. Okay, this is the question that you're given. Then you need another table like this one, So first of all, if you want, you can first start by finding the weighting root factor. Okay, weighting root factor, you find it by using that formula. Okay, here the maximum is 100, and this is from 0 up to 100, so the maximum is 100. And after finding this one, now let me show you how you can find these values here. Okay, so what you do here is that let's take an example of you also need to consider the soil type. Okay, you also need to consider the soil type. So now let's say we are getting bulk density, or maybe available water capacity here. So for at 0 to 25 centimeters, we have about 0.18. Then you need to find the graph which shows the sufficiency levels of these values here. So available water capacity, we can let me see if we can, on this graph, AWC, can I see it? Sufficient available water capacity. Okay, it is here. So here, this is the sufficiency level. This is the sufficient level in like x-axis, in y-axis, sorry. Then x-axis, you have, that is where you have those values. So you come here and find where 0.18 is, which is this value here. Then you come up like this, come here, you hit this part, come here, okay? Come here, come here, yeah, something like in between here. So this is a value between 0.8 and 1. So this is more like 0.9. So you record that value here. Okay, this is 0.9, because you have, for all the depths, you have 0.18 as available water capacity. So you also come for bulk density here. You have pH here, and then you have gravel here. So these again, you come based on these numbers. You can here, let's say bulk density is here. Now bulk density has got so I'll go straight to bulk density because the rest, everything is just the same. Now bulk density and of course gravel, they have got all types of soils. Okay, so then I'll show you how you can also identify. So you take note of the soil type, which is clay. Then bulk density, let's go for, let me check first. If I go for 1.3, it's straightforward, because where is bulk density? Because 1.3 is where all the lines are meeting, which is 1. Yes, which is 1. Now I'll go for 1.4. So when you come here on your bulk density 1.4 is here. Now you come to the legend here, or the key. You identify which one is your clay, the type of soil. So this is this one to my dot with like is it a square in between, is your clay. So you come and identify where clay is. Clay is here. Okay, clay is here. This line is for clay. Okay, So if we were, this is another type of soil, this is another, so you need to consider the type of soil that you have so that you know the right curve to follow. So 1.4, if we are to come here, 1.4 is here, this line here, until it hits, then it goes this side, sorry, this side, okay, here comes this side. So the value is 0.6. So then you put that one in the table, okay, 0.6. So now we have all the values. This one is calculated, and also these are calculated from these graphs. You're getting these figures, all of them. So productivity index, you're just multiplying these. You multiply, then this is your answer. Also here at this, so these are root zones, you can say, or horizons, number 1, number 2, number 3. Then you add all those 3 or whatever number that you have to come up with the overall productivity index. So you add this, and then you come up with this one. Now this is more like a percent. It's a percentage that gives you the maximum, the yield based on what you have, the yield that you can get from the maximum expected yield expected per hectare. Okay, now when you come to, okay, here it goes. So 52% as the overall productivity index. So that means if in a hectare you are expected to have the maximum yield of 5 tons per hectare, then that means you just get 52% of this, so which is 2.6 tons per hectare. Okay, now coming to the exercise that you are given, you do the same, of course. So exercise number 1, I'll try to explain exercise number 1 because it's just similar with the exercise number 2. It's actually the same question, that few figures are changed. Okay, the concept is the same. So a farmer wants to grow maize and has the maximum yield of 7 tons per hectare. Given the data below, determine the productivity and the yield, the maize yield on this land. Okay, so then number 2, assume that 5 centimeters of the topsoil has been lost through erosion. Determine the resultant decline in the productivity of the yield. Okay, now let me just wrap this. It was was trying something. I'll explain. Just let me just wrap this. Takes so much time to remove one. Okay, so here we'll do the same. So you can first find the WFI, which is the root depth. So you can find that. You remember the formula for finding that. So you create another table which has got where you are putting the sufficiency levels. So after calculating using the root depth here, then you come to, now I needed let me see if question 2 has let me see if question 2 has different, okay, question 2 has got different soil types. This one is the same. So now here what you need is AWC. You go on the available water capacity curve, which is 0.18 here. here, you come here, which is 0.9, so your sufficiency level is 0.9, which interprets as 90%. So 0.9 here, everything. Then bulk density BD 1.3, and then the rest is 1.4. 1.3 bulk density, 1.3, which is 1, and then the rest, because this is clay, the rest is 0.6. You put those figures. Then you come to pH. pH is 7.8, and then the rest is 8. So 7.8 pH, 7.8 is here, and then somewhere here this value looks like in between, so also it looks like this is 0.9, and then where then 8 should be in between here, which is 0.8. Okay, so you put your figures, 0.9 here, 0.9, and then the rest 0.8. Yes, if I read correctly. Then gravel 6, you come also to the gravel graph. Where is gravel? Okay, gravel content. So you also look for clay. I guess this is the one, and it is the value for gravel 6. Gravel content. Okay, so gravel content 6. So I would recommend you use this graph here, sufficiency of gravel content here, this one here. So 6, you read your scale, this is 1 2 3 4 5, then this is percentages, so it means one small box is yeah, I think should be 0.4. Is it 0.4 or 4? Should be 4. Yeah, 4%. So again, so in between here, that is where you find your 6, and then it gives you 1. Okay, so then you put your 1, and then after putting all the values, you do the same. You multiply, and then add the over. Now I know the confusion, that's why I didn't even pay much attention explaining on how you can find the productivity index, because we just did that above there. So the confusion is where you assume that 5%, 5 centimeter of the topsoil has been lost. This one is also simple. I guess you can try it out, but if you want, because let's say this is the soil, okay, then you have 0 here. If this is your meter rule, and you are measuring the horizons, so you have 0 here, then there's 20 all the way up to 180, yes. So if 5 is removed, okay, 5 is removed, meaning you have lost 5 centimeters on top, maybe 5 is here, okay, then what remains, this will be your 5, 20, it continues. Now I think you can do this in 2 ways. If you want, you can leave the rest the way they are here, because now here the only thing that will change is the WFI, the rest remains the same. Okay, so you need to start calculating WFI, and we know the formula is simply max minus the first is it D? I'll put 1, okay, squared, minus D max minus D2 over 100, over D max squared. So this is D1 is the upper boundary, and then lower boundary. In this case, the upper is 0 and the lower 20. Then here 20 becomes upper, 40 lower, just like that. So you can say instead of starting from 0 here, you start from 5 to 20 and then you leave the rest the way they are. Or you can say you can change everything, then it becomes, though it's not reasonable. You can change everything and then maintaining the difference between these two numbers, or the range, which is I guess 40 or something. Maintaining the space between the two intervals or the ranges, but the answer will be the same. So meaning you can say, maybe say 5 to 20 to 25, then 25 to 45, just like that. But you can just, you leave these the way they are and then you just start from 5 to 20. The answer will be the same. After recalculating, then you can multiply and find the same. So try it out and then let me know if you have some more challenges. Then now the percentage that you're going to get, remember now we are getting two units. Number one, after finding, let's say you find is 50%, you multiply that 50% by 7, which is half of 7, so you are getting 3.5 per ton, per hectare. I mean 3.5 tons per hectare. Then after you have done that one, definitely to reduce, let's say maybe it goes to 40 or 45, again you multiply that percentage by 7, then maybe to give you 2 point something or maybe 3 or something, I don't know. So just do that. If you have problems, let me know in the comment section, then I'll be able to explain again. Thank you.